So if you talk of movement in the cloud, 80% have migrated to workloads to cloud, portability across environments, and they want to avoid cloud vendor lock-in. So the applications are transforming from monolithic to slow changing to big servers. Yeah, sometime in the 2000s, and then when you compare it with today, there is a lot of transformation in the kind of application. So when you look at application modernization, so we have the application code. So here there are certain developer issues. So minor code changes require a full recompile and retest. Application becomes a single point of failure, and application is difficult to scale. So when you look at some kind of microservices, what is a microservice? So you are going to break the application into separate operations. So when you look at certain factors, so you need to make the app independently scalable, stateless, highly available by design. So when we look at continuous integration and delivery, so we have three stages. The first one is called development. The second one is called test. The third one is called production. So you have a developer who writes or develops the code, then that is basically fed into a version control system. Then you pass on the code that is developed into testing. Then in the testing we basically pass it on to the QA team, and then you go for what is called the production stage. The production stage also involves sysadmin as well. So there is always a tug of war between the developers and the operations team. If you look at developers, developers definitely have freedom to create and deploy the applications faster, and they will probably define and package the application needs. When you look at IT operations, so they will be able to quickly and flexibly respond to changing needs. Also, things need to be standardized, then they need to be secure and managed. So when you want to do all of these things, we will probably make use of what is called a Docker. When you look at organizations need to deal with diverse technology. For instance, bare metal, on premises, the operating system might be Linux. It could even be on a cloud, it could be Windows. You would probably be using some kind of traditional technology, or you would be using microservices. When you look at diverse organizations, again, there is a lot of diversity among developers and IT operations team. Now we would like to solve this problem and try to bridge the gap. We will see how probably you could do. So you have something called the myth of bimodal IT. So for instance, if you talk of microservices versus traditional applications, microservices might use the cloud infrastructure. Most of the traditional applications use the older infrastructure that are available. So this is called the myth of bimodal IT. Now we would like to enable this journey, and how we are going to enable this journey is I introduce something called that agile traditional applications in between microservices and traditional apps. This kind of an agile traditional application is found to be both past and future proof. So these kind of agile traditional apps will probably make use of the cloud infrastructure. They can also adapt to the old infrastructure as well. Now we look at the Docker and container overview. Okay, so what is a Docker, what is a container, and so on is what we are going to see now. So here, if you see the history of a Docker, it came into existence sometime in 2004 by the introduction of the Solaris containers, Sun Solaris, which you might be knowing. Then 4 years down the line, Linux containers got introduced. Then 5 years again down the line, we had something called, the Docker. So the Docker came into existence in 2013. In March of 2013, the Docker was made an open source. The first commercial product was introduced in February 2016 and they called it the Docker Enterprise Edition. So today where we stand, since Docker is an open source community, we have 3,300 plus contributors to this Docker, and that is a pretty huge number. Soon after the Docker was introduced and then announced as an open source, in a matter of about 4 years' time, about 14 million hosts run on Docker, 900k applications use Docker. There is a 77k% growth in the job listings, and something like 3,300 project contributors for Docker, and that is quite a good number, for an open source technology down the line in just about 4 years' time. So when you look at the Docker family tree, see, we have an open source framework. So introduced by the Mobi project, the open source framework for assembling core components. So there are two versions to it. We have the Docker Enterprise Edition and the Docker Community Edition. The basic difference between these two is the Docker Enterprise Edition is subscription based, commercially supported. The Docker Community Edition is free. Anybody could probably download and use it. So this is a community supported product for delivering a container solution. So when you look at the history lesson, so it probably says, one application on one physical server. So you have the application, you have the operating system, and you have the physical server. Yeah, this is called the dark ages. When you look at the historical limitations of application deployment, you have slow deployment time, huge cost, resources are wasted, it is difficult to scale, it is difficult to migrate, and there is something called the vendor lock-in. These are certain historical limitations of the application deployment. So again, when you look at the history lesson, we have something called the hypervisor based virtualization. What is hypervisor based virtualization? There is one physical server, and this physical server will contain multiple applications. Each of these applications will run in a virtual machine. Yeah, so there is one physical server, it could contain multiple applications, and each application will run in its own virtual machine. So what are the benefits of virtual machines? That is what we want to see. When you look at some of the benefits of virtual machines, you have better resource pooling, it is easier to scale, and virtual machines in the cloud have a high and rapid elasticity. And another key advantage of these virtual machines are it is something like pay as you go model. So one physical machine will basically be divided into multiple virtual machines. Yeah. So this is some kind of a benefit that a virtual machine would probably offer. So these are some of the kinds of benefits that a virtual machine has to offer. So we would also like to see what are the limitations of these kind of virtual machines. So each virtual machine requires some kind of CPU allocation. It will definitely require storage. It will definitely require the RAM, and obviously it will require an operating system. Whenever the number of virtual machines that are running increases, resources required also increases. So when you go for using something called the guest OS, obviously it leads to wasted resources. Another problem that you might find here is whenever you go for using a virtual machine, the application portability is not guaranteed. So because of some kinds of issues like this, we need to solve this problem of using the virtual machines, and so this problem could obviously be solved by using what is called a container. So what is a container? A container is a standardized package for a software. In addition to that, you should also remember that it is a package for a software and its dependencies too. This container is useful to isolate the applications from one another. The container can share the same operating system kernel, and this makes a key advantage that you need not probably use what is called the guest OS. Another key advantage of a container is this container works with all major Linux and Windows servers. So that is another key advantage of using a container. So when you probably want to you know try to compare and contrast a container and a virtual machine, it's going to be probably simple. Yeah. So when you look at using a container and a virtual machine, by looking at this diagram, it is very clear and obvious that a container makes use of an Docker built above the host operating system, whereas if you talk of using a virtual machine which is built on a hypervisor, it also makes use of what is called the guest OS. This guest OS basically leads to a lot of wastage of resources. So that is why we would obviously say a container is more advantageous than a virtual machine. So the next obvious question that is coming to your mind is whether virtual machines are going to be useless. So shall we discard it? No. If you can probably combine the powerful features of the container and the virtual machine together, you are going to get tremendous amount of flexibility. You will be able to optimally deploy and manage your applications. For instance, you can clearly say, when I use a container with a Docker, I can use it for development, and then I can combine it with a virtual machine like a hypervisor, the guest OS, and so on the production line. And when you can probably combine the powerful features of the container and the virtual machine together, definitely it is going to be much useful. This basically provides huge amount of flexibility for the IT, and it will optimally deploy and manage your applications. So the next obvious question is, okay, I will use the Docker container. What are going to be my key benefits? Or the next question is, what are the key takeaways of Docker container? So there are three key things you can always remember. Number one, speed. Number two, portability. Number three is efficiency. When you talk of the speed, there is no operating system to boot. The application that you are going to use is going to be online in seconds. The second one is portability. There is always very less dependency between the process layers. So there is always ability to move between infrastructure. And third is what is called efficiency. Obviously there is less amount of OS overhead and there is improved VM density. So these are some kind of key benefits that come along when probably you try to use a Docker and a container. So what we need to know when you are probably interested in using a Docker. So some of the basics you should understand when you try to use a Docker are something called an image. This image will serve as the basis for a Docker container. Then you have a container. The container is nothing but the image that is running. The next one is called the engine. So what is the engine? The software that executes the command for the containers. Then you have something called the registry. Registry will store, distribute, and manage your Docker image. And then I have something called the control plane, which will manage the container. So if you look at what could be the foundation for me to work on a Docker application, the foundation to work on a Docker application is nothing but the Docker engine. So what is a Docker engine? A Docker engine basically has some things like, integrated security. That is the key feature of the Docker engine. So what is integrated security? So you have security, network, distributed, statistics, container runtime, orchestration, and so on as part of the Docker engine. So we have a set of developers, we have a set of IT operations team. The developers will probably manage the microservices and some kind of traditional services that are running. So the image registry that basically lies between the developer and the IT operations will basically, serve as a bridge between the developer and the IT operations. So the image registry basically serves as a bridge between the developer and the IT operations, and that is how it will be possible to build a software supply chain. So we have seen that you can use containers as a service. It is called CaaS in short. In the further slides, when I say CaaS, it is nothing but containers as a service. So it probably takes into account both developers and IT operations. So if you look at the building, shipping, and running, so the clients pull and push the images. Then you have an image registry where the images are stored in repositories. Then you have something called the run. Run means, execution, right? So the engines will run on the servers in the cloud or the data centers. So nowadays, it is mostly the cloud. Cloud probably, takes a lot of, importance nowadays. So the overall objective is to build a secure supply chain. The next question is, how do I build a secure supply chain? Yeah. So that will obviously be possible here. So I have usable security, trusted delivery, and all the applications are portable. So this kind of a container app lifecycle workflow is very, very important. And this will probably form the basis for building a secure supply chain. Now we quickly, in about 5 minutes, look at what is a Docker Enterprise Edition has to offer. So these slides are more or less generic, just for you to understand, how important the concept of a Docker is in the real-time industry applications. The Docker basically aligns to multiple IT initiatives. 3 out of the 4 top initiatives are app modernization. 80% looks at Docker for cloud strategy. You might be aware of this platform. The cloud, the most commonly spoken word, the buzzword in the IT is the cloud nowadays, right? And 44% are looking to adopt DevOps with Docker. So Docker is in the enterprise, no doubt. So this slide basically shows you how the Docker is adopted in the enterprise. If you look at this slide, it basically shows, irrespective of the type of industry, Docker finds its applications, right from service provider to healthcare to technology to insurance to public sector. Docker is in the enterprise. So Docker also delivers agility, security, and cost savings. So if you look at this, you will obviously understand that Dockers deliver agility, security, and cost savings. Almost the maintenance costs are reduced by 10x times. So how do you know that? So looking at the slide, the use of a Docker basically helps to eliminate work on machine issues. It is 13x times more software releases, 65% reduction in developer onboarding time, and so on. And this slide basically drives in how a Docker is much better than the other kind of traditional applications. So to put it in a nutshell, what is a Docker? A Docker is said to be one platform and one journey for all applications. So traditional apps in containers, then you transform them to microservices, and then you accelerate new applications. And this basically shows you how a Docker is basically gaining importance in the real-time industry. So some kind of certified technologies extend the platform with assurances and support. I will show you that, and with that we will probably close the class for today. There are a lot of certified technologies, for the Docker. So you could see something like Red Hat, Oracle, Ubuntu, Azure, Amazon Web Services, and all of these things. They are certified technologies that extend the platform with assurances and support, and all of these basically extend their support to the Docker application, and that is why a Docker gains much of importance. So that concludes the concepts of a Docker and how a Docker is basically important.